Hi everyone, this is Nihar sir. So today class we will study your theory of machine, which is comes under your fourth semester automobile and mechanical branch. So in this theory of machine subject, there is a chapter 3 that is power transmission. In this chapter, there is a topic called length of an open belt drives. So before going to the topic, let us introduce what is belt, what is power transmission. So we know already known that power transmissions. The power transmission means the power can be transmitted from one shaft to another shaft through chain, belt, rope or gear. We have already known that in this way the power can be transmitted from one shaft to another shaft. But where we use the chain, gear or belt and where we use other things. That means when the two shafts are very distance apart, so when the two shafts are very distance apart, then we can say here we use the chain drive, the belt drive or the rope drive. And if the two shafts are very close to each other or nearer to each other or very small distance apart, then we can use gear drive here. So this is clear where we use gear drive and where we use chain, belt or rope. Next, what is the types of belt? Belt, what are the types of belt? We have known that there are three types of belt. First one is your V belt, second one is your flat belt, and third one is your circular belt. The first one is your V belt, you know that, and the second one is your flat belt, and finally the third one is your circular belt. So where we use V belt, where we use flat belt, and where we use circular belt. Before that, let's see what is V belt. V belt, you know that belt are used in pulley. Over the pulley, belts are there. So first draw the pulley here. Here you can see this is the pulley. In case of V belt, the belt is like that. This is hatching area is your belt. So this is called V belt. Then what is a flat belt? Flat belt means this is your pulley, and above the pulley the belt is there. This is the flat belt. That means the surface of the belt will be flat. Then again, what is circular belt? Circular belt you will see if this is the pulley, the circular belt means the surface is circle. Belt surface is circle. So this is the circular belt. So three types of belt: V belt, flat belt, and circular belt. So V belt. First we will see V belt. Where we use V belt? V belt is used in the factories and workshops where moderate amount of power is to be transmitted. Where moderate amount of power is transmitted, we can use V belt, and the pulley should be very near to each other. The pulley should be near to each other. Next, we will study what is flat belt. So flat belt is used in the factories and workshops where again moderate amount of power is to be transmitted and the pulley distance or the shaft distance is below 8 meters. Below 8 meters, if the two shafts is below 8 meters, then you can use flat belt there and power transmission is moderate. Then the third one is your circular belt. When we use circular belt, the circular belt is used in the factories and workshops where the greater amount of power is to be transmitted. Where the greater amount of power is to be transmitted, we can use circular belt. Again, when the two shafts pulley are at a distance 8 meters above 8 meters apart, then you can say use circular belt. So this is clear. V belt, flat belt, and circular belt. Now we will study what are the types of flat belt drives. Flat belt drives types. This is also three types of flat belt drives. The first one is your open belt drive, second one is your cross belt drive, and third one is your compound belt drives. We have already known that before to calculate length of the flat belt, we have introduced this. So there are three types of flat belt drives. First one is your open belt drive. In case of open belt drives, you know that there are two pulleys. One is your larger pulley, then one is your smaller pulley. If the direction of the two pulleys are rotated in the same direction. If the two pulleys rotate in the same direction, that means if it rotates in the clockwise direction, then another one is going to rotate in the clockwise direction. This is your driver and this is your driven or follower. If the driver and follower are rotated in the same directions, then you can say it is an open belt drive. And in case of open belt drive, the below side of the belt you can say tight side. This is called tight side, and the above side of the belt we can say slack side. This is slack side. What happens in case of open belt drive? The pulley pulls the belt from the lower end and delivers to the outer end. So this lower end becomes slack side, tight side, and the upper end becomes slack side. In case of open belt drive, you see open belt drive. So what happens in case of cross belt drive? You will also see that in case of cross belt drive, the driver and follower are rotating in opposite directions. So what happens? You will see this is driver pulley and this is follower or driven pulley. If the belt look like this, if the belt look like this, then you can say it is a cross belt drive. Open belt drive, this one is your cross belt drive. In case of cross belt drive, the driver rotates in clockwise direction, whereas the driven rotates in anti-clockwise direction. So, where the driver and driven rotate in opposite directions, you can say it is a cross belt drive. In case of cross belt drive, the same downward side is your tight side and the upward side is your slack side. Same. Tight side, slack side, same. But the direction of rotation of driver and follower is different for open belt drive and cross belt drive. Then the third one is your compound belt drive. What is that? Compound belt drive. So what happens in case of compound belt drive? You will see in open and cross belt drive there are only two pulleys, driver and driven. If the power is transmitted from the driver pulley to the driven pulley through several pulleys, then you can say it is a compound belt drive. Here you will see the first from pulley 1, the power is transmitted to pulley 2. It is open belt drive. Then power from pulley 3, it is transmitted to pulley 4. So this case we can say compound belt drive. So in case of compound belt drive, the power is transmitted from the driver to the follower through several pulleys. If power is transmitted through several pulleys from one pulley to the driver pulley to driven pulley, then you can say it is a compound belt drive. So it is compound belt drive. So these things we have already discussed in the class. Now we will discuss what is the length of an open drive. Here you will see this is an open belt drive. Now we will calculate the length of an open belt drive. So before going to the length of an open belt drive, first we will draw the open belt drive diagram carefully. Here you will see in the right hand side. In case of open belt drive, we know that there are two pulleys. First one is your driver pulley. This is slightly larger, and next one is your driven pulley. This is smaller. Larger pulley is your driver, and smaller pulley is your driven. The center of the larger pulley is your O1. The center of the smaller pulley is your O2. Right? Then, in case of flat belt drive, what happens? The belt. Look here. The belt. How belt will go from the larger pulley? The belt will go like this. It will enter the smaller pulley here, and now it will leave the pulley and enter C. This is the belt drive, open belt drive. So where it will touch, that is E, F, and this is G, this is H. See, the left side that is your J, the right side that is your F. So the angle at which the belt leaves the larger pulley, that makes angle alpha. Here below the same angle alpha, and the angle at which the belt touches the smaller pulley is your alpha. Here in the below side is also same. And here see, in case of open belt drive, the direction of driver or larger pulley is equal to the direction of the smaller or driven pulley, right? Here is this is the diagram of an open belt drive. Open belt drive. Okay. So what we have already known that in case of open belt drive, the direction of rotation of the driver or larger pulley is equal to the direction of rotation of the smaller or driven or follower pulley, right? So now we will make a O to M which is parallel to EF. So making EF parallel, we will draw a line O to M and which is perpendicular to O1. So making parallel with EF, we will draw a line O to M. Here is M, and which is parallel to EF. EF is parallel to O to M, and O to M making perpendicular at O1. And the angle that is AM O to O1 is your alpha. AM O to O1 is your alpha. So here complete. So before that, we will know the radius. The radius of the larger pulley is your R1, and the radius of the smaller pulley is your R2. Larger pulley radius R1, smaller pulley radius R2. And the distance between the larger and smaller pulley center, that is your x, small x. That is your small x. Is the distance between O1 and O2, center of the two pulleys. So we have already known that open belt drive, the direction of rotation of driver and follower is same. Then make a parallel line which is parallel to EF. Make a parallel line O to M which is perpendicular to O1E. And the angle between AM O to O1 is your alpha. Complete. So now we will know what are the unknown terms. So let what R1 and R2. We have already told you that. What is R1? R1 is the radius of larger pulley. What is R2? R2 is the radius of smaller pulley. So R1 and R2 equal to radii. Radii is the popular form of radius. So radii of larger and smaller pulley respectively, R1 and R2. Next is your small x. What is small x? Small x, the distance between two centers. So small x equal to the distance between two centers of the pulley. Next, what is capital L? We will calculate this capital L. What is L? Total length of the belt. In between two pulleys, there is a belt there. So we will calculate the total length of the belt. So capital equal to total length of belt. This is the total length of the belt. We will calculate this. So before going to the topic, let's see. So in this figure, so we know that total length of belt. So from this figure, let me tell you what is the total length of the belt. That is capital L. Total length of the belt is your capital L. So what is capital L? See the G, J, E. It will be a what? Arc. It is arc. So the arc G, J, E plus E, F plus another arc F, K, H plus G, H. So this is the total length of the belt. The arc G, J, E plus E, F plus the arc F, K, H. This is K. F, K, H. So we will write first one is your arc. Arc G, J, E plus E, F plus is your arc F, K, H plus G, H. So this is the total length of the belt. Again, the arc G, J, E. What is the midpoint? That is J is the midpoint of arc G, J, E. So we can say right, the twice of arc J, E is the total of the arc G, J, E. So here you can write in place of arc G, J, E, the twice of arc JE. Twice of arc JE is your total arc JE. Similarly, plus EF, in case of EF, we can write EF plus. Similarly, we can write for the total FK arc, we can write twice of arc FK. So arc FKH, we can write twice of arc FK. Complete. Plus, in place of GH, we can write EF because from the figure you will see the length of EF equal to the length of GH. So in case of GH, we can write EF. So in the side, we can write EF equal to GH. Okay. So the equation becomes this is twice of arc JE, this is twice of arc FK, and here FEF, here also EF. So twice of EF. So write 2 into arc JE plus 2 into EF. You can write 2 into EF plus 2 into arc F. L equal to. That implies, so here 2, here 2 multiplied, here 2 multiplied, we can say common. Take 2 common, then what will write? Arc JE plus EF plus arc FA. So make it equation 1. Make it equation 1. So first we will calculate what is the value of arc JE, what is the value of EF, and what is the value of arc FJ. Then substitute these three values in equation 1. So remind equation 1. First we make a note, then we will erase it, then we will calculate these three values. Okay? Make a note. I will write this equation 1 above part, right? So in equation 1, there are 3 points, that is arc JE, next EF, next arc FK. So we will calculate these three values. So first we will calculate what is arc JE. From the figure, you will see arc JE equal to how much? Arc JE equal to how much? This is arc JE. So how we will calculate the length of an arc? That means first we will see the radius, and within with the radius we will multiply the angle. So what is the radius of the larger pulley? R1. So arc J equal to R1 into multiplication of the angle. Angle means from J to E. This was the angle. So this is right angle and this is alpha. So right angle means pi by 2 or 90. So you can say pi by 2 plus alpha. Again I will tell arc JE, the length of arc JE we will find out by multiplying the radius with the angle. So the radius we know that R1 and the angle is the total angle. Total angle is here from here 90 and this much is alpha. So 90 plus alpha. This is the arc JE. Similarly, arc FK. We will find out arc FK. Here we will see in the figure the driven or follower pulley. The radius of the follower pulley is your what? R2. So R2 into multiplication of angle. The angle is from K to F. This is the total angle 90 or pi by 2, and this is the angle alpha. So if we will minus 90 minus alpha, we will get the angle F2K. That is pi by 2 minus alpha. So we will find out the two values, that is RJE and RFE. Now we will calculate what is the length of FEF and what is the length of GH. Before that, first we will see in a triangle. O1, M, O2. Here we will see O1, M on O2 is a right angle triangle. O1, M, O2 is a right angle triangle. From the right angle triangle, we will find out what is sine alpha. Sine of alpha. Sine of alpha means the front end here. So sin alpha equal to is your O1m divided by O1 O2. Sin alpha means O1m divided by O1 O2, right? So equal to O1m. This part is your O1m. This total is your O1e. If we will subtract O1e, if we subtract O-M-E from O1e, the larger part is your O1e, the smaller part is your ME. If you will subtract ME or EM from O1e, we will get O1M. So what is, we can write O1M equal to O1e minus EM. See here in the figure, O1e minus EM equal to your O1M divided by, that is your O1O. Why we will subtract here? Because we will want to get the perfect value. So we know that O1e, that is O1e. What is O1e? O1e is the radius of the larger polygon. So radius of the larger polygon how much? R1 minus. What is EM? We know that EM is parallel to O1F. So we know that O2F is your radius of smaller polygon, and the radius of smaller polygon we know that R2. So EM equal to O2F equal to R2. So R1 minus R2 divided by, what is O1 O2? The distance from center of larger polygon to center of smaller polygon. That is what? X. So 1 O2 you can write X. So sin alpha equal to R1 minus R2 by X. But here you will see the value of alpha is very small. So value of alpha is very small. We know that if the value of alpha is very small, we can write sin alpha equal to alpha. H sin 0 equal to how much? 0. So H sin 0 equal to 0. So the value of alpha is 0. Then you can say sin alpha equal to alpha. So here we will write sin alpha equal to alpha equal to R1 minus R2 X. So in place of sin alpha, you can write alpha, and in case of alpha, you can write R1 minus R2 by X. So remember that alpha is equal to R1 minus R2 by X. Make a note. Then we will derive. So in the equation 1, after is the, what is the RFK plus EF plus RJE. We have calculated RJE, we have calculated RFK. Now we will calculate what is EF. So now EF equal to, you will see what is EF. EF equal to, we know that EF is parallel to O2M. In place of EF, we can write O2M. We know that O2M equal to EF. So, what is O2M? O2M from the right angle triangle. This is a right angle triangle. You know that. From the right angle triangle, O2M equal to root over under O1 O2 square minus O1M square. Correct? So EF is parallel to O2M, and the value of O2M equal to root over under O1 O2 square minus O1 M square. Okay. What is O1 O2 square? O1 O2. The distance from O1 to O2 is your X square minus O1 M. In the previously we have calculated what is O1 M. That is O1E minus EM. Okay. O1M equal to O1E minus EM square, or equal to root over under X square minus what is O1E. You know that O1E, that is your larger radius pulley, that is your R1 minus what is ME or EM, that is your radius of smaller pulley, that is R2. So R1 minus R2 square. So what is that? EF equal to X square minus R1 minus R2 square. We can write this form. That means if we divide X square on both the terms, that is X square. If we multiply an X square, divide an X square, right? X x square multiply, that is x square by x square minus r1 minus r2 square by x square. We will make a multiply x square divide x square. There will no effect. Then what will happen? Under root over x square, this will be 1 minus r1 minus r2 by x whole square. Yes. If we will remove this x square from the square root, then how? What will happen? This becomes x. Square of root is x. X whole bracket 1 minus r1 minus r2 by x whole square. This is value of e. They cannot. So now, if we will expand this equation by using binomial theorem, if you will expand this equation by using binomial theorem, what will come? See, expand this theorem by using binomial theorem, we will get EF equal to x square bracket 1 minus half r1 minus r2 by x whole square plus dot dot dot. If we will expand this equation by using binomial theorem, then we will get this. This dot dot will come. After that, we can write EF equal to, if x will multiply there, then what will come? X minus r1 minus r2 square divided by 2x. Then it will become EF equal to x minus r1 minus r2 square divided by 2x. So now we have already calculated the three values, that is r EF plus the value of r JE plus EF plus the value of r FK. So now putting, so right, you can write now putting the value of r JE, EF, RFK in equation 1 we get. So what will be there in equation 1? Equation 1 is L is equal to 2 into RJE plus EF plus RFK. So we will put in place, we will write what is equation 1. Right? What is equation 1? Right? L equal to 2 into RJE plus EF plus your RFK. So this one is your equation 1. We will put the value of RJE and EF and RFK in equation 1 and see what will be there. So you will remind EF equal to x minus r1 r2 square by 2x. So L equal to 2 into, what is the value of RJE? We have already calculated what is the value of RJE. That is your R1 into pi by 2 plus alpha. Yes or no? Yes. Plus, what is the value of EF? We have calculated this right now. So x minus half is your R1 minus R2 square by 2x. Sorry, R1 minus R2 square by 2x. This is the value of EF. Next, what is the value of RFK? We have calculated RFK is your R1 into pi by 2 minus alpha. So this is the value of RJE, REF and RFK. Right? So now, in the next step, what we will do? First we will multiply R1 with pi by 2 and alpha. Then R1 with R2 into pi by 2 plus pi by 2 minus alpha. So what will happen? R1 into pi by 2 plus R1 into alpha plus x minus R1 minus R2 square by 2x plus here R2 into pi by 2 minus R2 into alpha. This will come again 2 into, we will make nearer to R1 pi by 2, here pi by 2, here alpha. So make close to pi by 2, alpha and alpha. So what will happen? R1 into pi by 2, this is plus R2 into pi by 2. Okay. Next plus R1 into alpha here minus R2 into alpha. Okay. Next is here x minus R1 minus R2 square by. Okay. Now make multiplication of 2. 2 multiply with each term. What will happen? 2 into R1 into pi by 2. What is R1 into pi? These two to cancel out. Plus these two to also cancel out. So what is it? R2 into pi plus this R1 minus R1 into alpha, then R2 minus R2 into alpha. So make sorry. First we will take common pi by 2. Okay. So what is pi by 2 into R1 plus R2 plus, if you will take common alpha, then it becomes R1 minus R2. Next, this is same x minus R1 minus R2 square by 2x. Now in the next step, we will multiply these two with each term. So what will happen? These 2 and 2 cancelled out. So the remaining part pi R1 plus R2. Here 2 into alpha, we will multiply here. So 2 alpha R1 minus R2 plus x. This will be same x minus R1 minus R2 square by 2x. So this will come. I cannot solve. Now in the next part, we will put this alpha value. Before we have already calculated what is alpha, I will remind you that I written that if the angle of alpha is very small, we can write sin alpha equal to your alpha equal to R1 minus what will write alpha sin alpha equal to R1 minus R2 by x. So putting the value of alpha equal to R1 minus R2 by x in the above expression we write. So write alpha is sin R1 minus R2 by x. So capital L equal to pi R1 plus R2 plus 2 into. So in place of alpha, we can write R1 minus R2 by x. We have already studied in the previous. So remaining part R1 minus R2 plus x minus R1 minus R2 square by 2x. Sorry, when we multiply 2, these 2x will be cancelled out. The remaining part is your x. So now here you will see pi R1 plus R2 plus 2 into R1 minus R2 square. So R1 minus R2, here R1 minus R2, it becomes square divided by x plus x minus R1 minus R2 square divided by x. So this becomes 2x now. When we will multiply 2, it becomes 2x. Here you will also 2x, right? Now this R1 minus R2 square by x, here you will also R1 minus R2 by square x. This makes common, right? So pi R1 plus R2 plus, if we will take common R1 minus R2 square by x, then the remaining part is here 2 minus here nothing, that means 1 plus the remaining part 2x. So what will happen? L equal to pi R1 plus R2 plus here 2 minus 1 is 1. So R1 minus R2 square by x plus 2x. This is the value of length of an open belt drive in place of pulley radius. So make a box and here write in terms of pulley radius, popularly plural form is your radii. So this is the formula for length of an open wheel drive in case of pulley radii. L equal to pi R1 plus R2 plus R1 minus R2 square divided by x plus is your 2x. Then, if we will calculate the length of an open belt drive in terms of pulley diameter, if there is pulley diameter given, then what is the value of length of a open belt drive? So we can say write L equal to pi. In case of radius, we can write diameter. So what is the diameter? Diameter is the twice of radius, or radius equal to diameter by 2. So pi d1 plus d2 divided by 2, right? Plus, in case of radius, you can say right diameter. So d1 minus d2 square by 4x, because r equal to d by 2. So half square is equal to 1 by 4 plus 2x. So make it works and write that is your in terms of pulley diameter. In terms of pulley diameter. So these are the two value of length of an open belt drive in case of pulley radius and in case of pulley diameter. In case of open belt drive, so length of an open belt drive, length of a belt in case of open belt drive. In the next class, we will study length of a belt in cross belt drive. In case of cross belt drive, what is the length of a belt? We will calculate in the next class. So in this class, we will calculate the length of an open belt drive in terms of pulley radius and in terms of pulley diameter. I thought you will all understand this. Thank you for the class.